This is part 4 of PIC game programming. In this episode what I'll do is I'll go through the software design of the PIC game. So first of all, I initialise the hardware of the PIC microcontroller. Once that's out of the way, you don't have to worry about initialising the hardware again. And then initialise the settings, and the settings are the level and the sound on-off settings. If this is done first, then we want to retain these settings, so do it early and then we don't have to go over that code again. And then initialize the software, so other settings in the software which we want to reinitialize for each game start. And it goes into a finite state loop, so this should go round and round, keeping the current state of the software and acts on whatever the current state is. So the first state it goes into is settings, and this allows the user to increment the sequence level, increment the LED level as well. The user can turn the sound on and off, or the user can start a game. Once the user starts a game, then this finite state goes into a different state. It goes into the game mode, and in the game mode it gets a random value and it adds it to the sequence of values which the player has to remember. And then it plays the sequence of values, and the user then has to play back the sequence of values and get it correct. It goes back up to the top again in the loop. It gets another random value, adds it to the sequence, so now there'll be two sequences in the sequences. And then it plays the two sequences, then the user has to verify two sequences, goes around again, 3 sequences, 4 sequences. That continues until either the player gets it right or gets a sequence wrong, and the game will either then they'll either win the game or lose the game. And then it goes back up to initialize software again. So this initializes all the variables to make sure that the game can start again without remembering anything from the previous game, but it doesn't initialize the settings, so it still remembers if the sound was on or off, and it remembers the previous levels which had been selected. And the only other thing it can do is, after a period of time where the user doesn't press anything, it can go into sleep mode. And from sleep mode, when the user presses a button, it will wake up. So that's in the finite state machine as well as a timeout period which it goes into if there's inactivity for any period of time. So the software breaks down into a few levels of that could be considered. First of all, there's the hardware level and initialization. So we would have an interrupt handler because the PIC microcontroller handles interrupts, and we use these for controlling the game speed, also for controlling the sound, so we can create frequencies using a timer, and also we use it to wake up when we've gone to sleep mode, so there's interrupts which will wake up the PIC microcontroller. Then it goes into initializing the application code, and then the next level would be to go into a finite state machine. So this is a position where the application spends most of its time just sitting, going around in a loop, deciding what the current state is, and depending on events that occur, which may be user events or maybe hardware events, it decides what it should be doing next. And then that state machine will make calls into an API. So we've got a level of functions which we could consider a programming interface. And then that API can also make function calls into what we could consider an operating system. So on the PIC microcontroller, because it's all about software and hardware, we can have a level which interfaces between the software and the hardware, and that keeps it as a separate level. Finally, just a quick view of how the resources are used on the PIC. So I've selected an 8-pin PIC, and it's one of the very basic ones. It doesn't have much in the way of memory. And of this application actually takes up most of the memory. There's only a handful of bytes left, maybe 14 bytes left, and then the RAM that's used, I use actually 63 of the 64 bytes, so it's really pushing the memory to its limits. And finally, the EEPROM, I'm using all of the EEPROM for lookup tables. So what's left over at the end of this program is very small amount of memory. So in the next part in this series, I'll start getting into the software writing, and I'll break it down into a series of steps which hopefully will be quite small, so we can cover a small amount in each stage and actually come up with some programs to demonstrate each small step, and finally build up to the full program, and I'll release the full source code for the program at the end.